So these are a few types of time series. So I hope you are able to observe the following from this. This chart 1 shows a repetitive pattern, alternating spike and depression continuously. Chart 2 shows a consistently decreasing trend. Chart 3 shows a consistently increasing trend with repetitive patterns. Chart 4 does not show any pattern, just seems to be a random output. We'll come back to these graphs again to see what they indicate. So meanwhile, we'll see what the components of a time series are. So these are my 4 components: trend, seasonality, cycle, and white noise. So trend is the long-term movement in a time series. So the trend can be an increasing or decreasing trend. Seasonality is predictable changes happening in regular calendar intervals. Say for example, cool drink sales are higher during summer. Sale of roses are higher during February, etc. Cycle is a rise and fall in the data which is not of a fixed frequency. The duration of the fluctuations is usually at least 2 years. It's often associated with the economy. So difference between seasonality and cycle is that while seasonality happens at regular calendar intervals, cycle is not of a fixed frequency. And moreover, the duration of cycle is at least 2 years. The fourth one, white noise. It is a residual part of a time series once you exclude the trend, the cycle, and the seasonality. So it results from short-term fluctuations in the data, which in some cases may not be predictable. Now we go back to the graph. Now that we are aware of the time series terminology, we can say now chart 1 has a seasonality but doesn't have any trend, meaning the level of the data is constant. Chart 2 has a decreasing trend but there is no seasonality. It could also be that we don't have enough data points for us to observe a seasonality. So the data is of 100 time periods. Suppose we had the data for 1000 time periods, probably there could be a seasonality evident. Yeah, chart 3 has an increasing trend as well as a seasonality. Chart 4 is just white noise. No trend, no seasonality, just white noise. So generally something called time series decomposition is done so that graphically we can identify if a time series has trend or seasonality. Unfortunately, it is not possible to do this time series decomposition in Excel. Even though we may be able to plot the data, and based on the plot we can find out if there is any trend or seasonality in the data. Okay, what are the steps to follow to do a forecast? The first thing will be problem definition. So what is the variable you want to forecast? Who will be using it? So what forecast accuracy would be needed? Say forecast for next time period would need to be more accurate than forecasting for a duration which is very much into the future. Some industries may require a higher forecast accuracy than others. So these are some points which you need to keep in mind while defining your problem. Gathering information. So you need to gather data. So first thing, do we have sufficient data available is your first question. So that seasonality, cyclicality can be captured if it is present. So there are cases when you have huge volume of data. So in this case, you need to decide, is my older data really relevant? So there could have been some changes in laws or changes in economic condition or operating model after some point of time, due to which the older data becomes irrelevant. So you need to decide, how far do I want to use my past data? Is my last 5 years data sufficient, or do I need 20 years data? So you need to make this decision while gathering the information for forecasting. Then you do some exploratory analysis. You check if there is any trend or pattern or seasonality present in the data. You check for any outliers or missing values. So a business judgment needs to be taken if outliers are present. Do they need to be removed, or do they need to be modified? Do they need to be averaged out? So this kind of business decision need to be taken in case an outlier is observed. Then you choose and fit a model. So we have a lot of forecasting models. You choose one model, the best model for your data, and try to implement it. Then you evaluate the model by comparing the forecast and actual values. We'll go into each of these methods one by one in subsequent video.